If you've been stepping outside after dark lately and wondering what that fuzzy smudge low on the horizon might be, stay tuned because by the end of today's show, you're going to know exactly what it is, exactly when to look, and exactly why you might only ever get one shot at seeing it. Welcome to Astronomy Daily. I'm Anna.
And I'm Avery. This is Season 5, Episode 91 of Astronomy Daily, your daily guide to everything happening in space and beyond.
It is Thursday, the 23rd of April, 2026, and we have a cracking episode lined up. 6 stories across the board today, from a game-changing telescope that just locked in a launch date, to a decades-old cosmic photograph getting a stunning update, to a signing ceremony happening literally as we record this.
And we'll close out with that comet you just teased, Anna, which our Southern Hemisphere listeners in particular are going to want to hear about. Trust us.
Let's get into it.
We touched on the Roman Space Telescope earlier this week when NASA hosted its big unveiling event at Goddard Space Flight Center. But since that story ran, something significant has become clear: the launch date. So let's give this the update it deserves.
Right, and the headline here is genuinely exciting. The Nancy Grace Roman Space Telescope is now targeting a September 2026 launch. That's 8 months ahead of its formal deadline of May 2027. 8 months. And it came in under budget. In government space projects, that is practically unheard of.
To put this in perspective for anyone just catching up, Roman is NASA's next flagship space observatory. Think of it as Hubble's younger sibling. Same size mirror, about 2.4 meters, but a field of view that is at minimum 100 times wider than Hubble's. The images it will capture are so large, there is literally no screen currently in existence big enough to display them at full resolution.
And NASA Administrator Jared Isaacman made a striking comparison at this week's press event. What would take Hubble 2,000 years to survey, Roman can do in a single year. 2,000 years versus 1. Let that sink in.
The science objectives are vast. Roman will hunt for exoplanets, potentially more than 100,000 new worlds in its first 5 years. It'll survey billions of galaxies, and critically, it will probe 2 of the deepest mysteries in modern physics: dark matter and dark energy. We don't know what either of those actually are, and Roman's wide-field infrared vision is designed specifically to pull back the curtain.
It's also carrying the coronagraph instrument, a technology demonstrator that will attempt to directly photograph planets around nearby stars. That could be a transformative capability for the search for Earth-like worlds.
Roman will travel to the Sun-Earth L2 point, the same orbital neighborhood as the James Webb Telescope, about 1 million miles from Earth. Once there, it begins a 5-year primary mission. If September holds, we could see first light before the end of this year.
16 years after astronomers ranked it as the single highest priority for the next decade of space science. 4 separate attempts to cancel the mission. And here we are, 8 months ahead of schedule, watching it ship to Kennedy Space Center this summer. Some stories really do have a good ending.
A feel-good story indeed.
Right, story 2, and this one involves Uranus, which is having quite a moment scientifically lately.
Uranus is the gift that keeps giving. The ice giant 7 planets out from the Sun, famously tilted on its side with 29 known moons and a system of 13 rings. And it's those rings at the center of new research published this week in the Journal of Geophysical Research, Planets.
A team led by Inke de Potter at UC Berkeley has combined data from 3 of the world's most powerful observatories: the W.M. Keck Observatory in Hawaii, the Hubble Space Telescope, and the James Webb Space Telescope, to build the first complete reflectance spectrum of Uranus's 2 outermost rings, known as the Mu ring and the Nu ring.
And what they found is that these 2 rings, sitting side by side in the Uranian system, are made of completely different stuff, which raises an obvious question: how?
The Mu ring, it turns out, is composed of water ice particles, tiny frozen grains being knocked loose from a small moon called MAB by micrometeorite impacts. MAB is only about 12 kilometers across, barely a pebble on cosmic scales, but it's generating an entire ring of ice debris as it orbits.
Interestingly, the only other blue ring like this in our solar system is Saturn's E ring, produced by volcanic activity on Enceladus. The mechanism is different, but the result is remarkably similar, nature finding the same solution twice.
Now, the new ring is where things get really strange. It's not made of ice. Instead, it's composed of rocky material laced with organic compounds, carbon-rich molecules. And crucially, there's no known moon nearby that could be the source.
The researchers believe there must be unseen rocky bodies, possibly small moonlets tucked between the known moons, getting bombarded by micrometeorites and feeding material into the ring. In other words, Uranus likely has more moons than we know about.
Mark Showalter from the SETI Institute, a co-author on the study, was pretty direct about it. He said solving the full mystery will probably require a spacecraft mission to Uranus, and one is in the planning stages. It was the top priority in the most recent National Academy of Sciences Planetary Science Decadal Survey, though funding remains the critical question.
There's one more wrinkle worth mentioning. The mu ring appears to be changing in brightness over time, subtly but measurably. What's causing that? Nobody knows. Another mystery for a mission that, fingers crossed, eventually gets off the ground.
Uranus, deeply weird, deeply fascinating, and apparently still full of secrets. This story is going to keep developing.
Story 3, and this one's a treat for anyone who loves cosmic imagery with a side of time-lapse astronomy.
The Hubble Space Telescope has gone back to one of its classic targets, the Trifid Nebula, and the comparison between the original image and the new one is genuinely remarkable.
For those unfamiliar, the Trifid Nebula is a star-forming region in the constellation Sagittarius, about 5,000 light-years from Earth. Its name comes from the Latin for divided into three. It's split into three distinct lobes by dark dust lanes, giving it this striking trilobate appearance. It's one of Hubble's most celebrated early targets.
Hubble first imaged the Trifid back in 1997, nearly 3 decades ago. The new image, captured with upgraded instruments, covers essentially the same field. And by placing the two side by side, astronomers have been able to track real, measurable changes in how young stars in the region behave and evolve.
Now, 29 years sounds like a long time to us. On cosmic scales, it's barely an eye blink. But young stars, still in the process of forming, still shedding material, still igniting, can show perceptible changes on human timescales. And that's exactly what the comparison reveals.
What Hubble is doing here is functioning as a kind of cosmic time-lapse camera, the same telescope returning to the same subject decades apart, and documenting how the universe has shifted in the interim. It's one of the most powerful aspects of having a long-lived observatory in space.
And of course, visually, the new Trifid image is spectacular. The deep magentas, electric blues, and soft golden hues of active stellar nurseries. If you haven't seen it yet, it's worth seeking out. We'll link it in the show notes.
The Trifid Nebula, 30 years older, and if anything, more beautiful than ever. Proof that some things genuinely improve with age.
Like us, maybe, Anna?
Story 4 now, and this one is happening today, right now as we record, at NASA headquarters in Washington, D.C.
The Hashemite Kingdom of Jordan is signing the Artemis Accords, becoming the 63rd country to commit to the framework for peaceful and responsible space exploration. NASA Administrator Jared Isaacman is hosting Ambassador Dina Cower for the ceremony.
Now, we should explain what the Artemis Accords actually are for anyone who joined us more recently. The Accords were established in 2020 during the first Trump administration by NASA and the State Department, initially with 7 other founding nations, including Australia. They're a set of practical principles covering how countries should conduct themselves in space. Transparency, interoperability, data sharing, protecting historic sites, safe zones around operations, and the responsible extraction of resources.
They're built on top of the 1967 Outer Space Treaty, but they add specificity that the original treaty lacked, and critically, they're open to any nation that wants to participate in the broader Artemis program of moon exploration.
What's interesting about the timing here is that just 3 days ago, on Monday, Latvia signed as the 62nd nation, though we've seen 2 signatories in 1 week, right on the heels of Artemis II's successful return to Earth.
There's a momentum story here. Artemis II returns from the moon, and within days, the international community is literally lining up to join the framework. Jordan, notably, has genuine aspirations in the space sector. The country has invested in satellite technology and space science education in recent years. This isn't just symbolic.
63 nations. The list now spans every inhabited continent, with 29 European nations, 15 across Asia, and representation from the Americas, Africa, and Oceania. The Artemis program is increasingly a genuinely global endeavor.
Congratulations to Jordan. Welcome to the coalition.
Before we move on to our next story, I'll just jump in and give you a reminder about our sponsor, NordVPN. They're the ones who are helping us keep the lights on this week. But if you're looking to make your online presence really secure from snooping eyes, and that includes governments, then you need NordVPN. They're the one we use and can highly recommend. Check them out via the link in the show notes, and I think you'll be amazed at the incredible deals they have in place for Astronomy Daily listeners.
All right, story 5. And if you're wondering how quickly NASA moves after a successful mission, wonder no more.
It was just 10 days ago that the Artemis II crew splashed down in the Pacific. 4 astronauts, home safe, after the most distant human spaceflight in history, and NASA is already rolling out the hardware for the next one.
On April 20th, just a week and a half post-splashdown, engineers at NASA's Michoud Assembly Facility in New Orleans loaded the core stage of the Artemis III Space Launch System rocket onto the agency's Pegasus barge. It's currently en route to Kennedy Space Center in Florida, where final integration and outfitting will take place.
The core stage is enormous. When fully integrated, it'll stand 212 feet tall, around 65 meters. What rolled onto the barge is the top 4/5 of that structure: the liquid hydrogen tank, liquid oxygen tank, intertank, and forward skirt. The engine section, with its 4 RS-25 engines, will be attached at Kennedy.
Now, Artemis III's mission profile has evolved since the program was first announced. The original plan, landing astronauts at the lunar South Pole, has been pushed back to Artemis IV, now targeting the first half of 2028. Artemis III, scheduled for 2027, will instead test rendezvous and docking procedures in Earth orbit, with the Orion spacecraft linking up with one or both of the contracted lunar landers from SpaceX and Blue Origin.
It's a sensible reconfiguration. Test the systems in Earth orbit first, where rescue is possible if something goes wrong, then send people to the moon.
And there's an added layer of significance here. One of those landers, Blue Origin's Blue Moon, was supposed to launch on a New Glenn rocket. That rocket is currently grounded following last week's upper stage mishap. So there's some pressure on Blue Origin to resolve that situation quickly. NASA Administrator Isaacman has expressed confidence publicly, but the clock is ticking.
The momentum of the Artemis program feels very real right now. One mission just returned, the next one is literally on a barge, the one after that is already in planning. This program is moving.
Next, something for our skywatchers.
That's right, the story I teased in the opener summary. And this one is especially for our listeners in Australia, New Zealand, and across the Southern Hemisphere.
Comet C 2025 R3 Pan-STARRS. It's been generating buzz for months. Some corners of the internet have called it the potential Great Comet of 2026. And right now, this week, is when Southern Hemisphere skywatchers get their best shot at it.
Let's set the scene. This comet was discovered in September 2025 by the Pan-STARRS Survey Telescope in Hawaii. At that point, it was a faint 19th magnitude speck, visible only to the most sensitive detectors. It's been brightening steadily ever since.
It reached perihelion, its closest approach to the Sun, on April 19th, passing within about 75 million kilometers of the Sun. And here's where it gets particularly interesting for our Southern Hemisphere listeners. While Northern Hemisphere observers have now largely lost it in the Sun's glare, the geometry is turning in your favor.
From late April through early May, the comet will appear in the evening sky for Southern Hemisphere viewers, moving progressively higher after sunset. At its brightest estimates, it could reach magnitude 3.5, comparable to the stars of the Southern Cross, and potentially brighter. There's even an optimistic scenario where it approaches magnitude 0, which would make it one of the most striking naked-eye comets in years.
Now, comets are famously unpredictable. We can model their orbits beautifully, but their brightness depends on how the icy nucleus responds to solar heating, and that's harder to forecast. The magnitude 3.5 estimate is a solid baseline, but don't be surprised if it over or under-delivers.
The closest approach to Earth happens on April 26th, just 3 days from now, when it passes within about 73 million kilometers. Look low in the western sky after sunset, in the direction of the constellations Pisces and Pegasus. Binoculars will certainly help, but under dark skies, you might find it with the naked eye.
And here's the detail that gives this story real weight. The comet's orbit may be hyperbolic. That means it may have come from interstellar space, will swing past the sun once, and then head back out, never to return. If that's confirmed, April and May 2026 could be the only time in all of human history that anyone ever sees this object. Ever.
So get outside this week. Dark sky, western horizon, after sunset. You might be watching something no human has ever seen before, and no human ever will again.
Before we wrap up, time for your daily dose of cosmic trivia.
Today's question: the Nancy Grace Roman Space Telescope shares its primary mirror size with a famous existing space telescope. Which one and where did the mirror originally come from?
I'll give you a second or two to think about it.
The answer: Roman's 2.4-meter mirror is the same size as the Hubble space telescopes. And here's the remarkable backstory. The mirror was actually donated to NASA by the National Reconnaissance Office. It was originally built for a classified intelligence satellite. NASA repurposed surplus spy satellite hardware into what will become one of the most powerful astronomical instruments ever launched.
From watching Earth from above to watching the universe from afar. Not a bad career change for a mirror.
And that is your Astronomy Daily for Thursday, the 23rd of April, 2026. 6 stories, 1 extraordinary universe. Thank you so much for spending part of your day with us.
Find us everywhere podcasts are found, on YouTube and at astronomydaily.io. Leave us a review if you're enjoying the show. It genuinely makes a difference. And follow us on social media at AstroDailyPod.
And for our Southern Hemisphere listeners, get outside this week. That comet is waiting for you.
Until tomorrow, keep looking up.
Clear skies, everyone.